Scientists believe that a planet that went supernova whenever the universe was barely 100 million years old may have left molecular traces. The first era's Generation 3 stars perished in huge supernova explosions that released the chemical elements that they had produced over the duration of their lives into the galaxy. Welcome back to Theory of Science. In today's video, we are going to see the supernovas destroying the stars. We see what exactly is happening in the planetary universe and how we can save the stars from this supernova. Watch the whole video for the details. Stars being the brightest objects and the most admirable one, we can't even think of some superpower destroying them. Maybe it's due to some cosmic radiation. Let's check the whole video to learn more about this. For more other facts about them, subscribe to this channel. How can a supernova destroy the stars? A supernova does not entirely destroy a star. The most ferocious explosions in the cosmos are supernovae. However, they do not detonate like a bomb, destroying the entire original device in the process. Instead, a star's core endures a supernova explosion. According to NASA, this is because the explosion is brought on by a gravitational rebound effect rather than a chemical reaction. Although most stars are turning out powerful hydrogen fusion processes, they are not what triggers supernovae. Because stars are so massive, the gravitational forces that hold them together are sufficient to prevent them from being destroyed by nuclear processes. A star is destroyed by a gravitational rebound. Understanding how these stars provided the world with heavy metals is essential to understanding the universe's development over its 13.7 billion year history, since this substance was absorbed in the following generation of stars, planets, and even people. But until lately, there was no hard proof that one of these earliest Generation 3 stars even existed. Astronomers categorize supernovae based on their light curves and the absorption lines of various chemical components that can be seen in their spectra. A supernova is categorized as a type 2 if its spectrum shows hydrogen lines, also referred to as the Balmer series in the visible section of the spectrum. Otherwise, it is type 1. There are distinctions within each of these two categories based on the existence of lines from other elements or the nature of the star's light. In order to study an extremely bright object powered by a huge black hole as it was 13.1 billion years ago, when the universe was just 700 million years old, a research team used the 8.1-meter Gemini North telescopic lens on the island of Hawaii. They found a cloud surrounding the item that had a particular chemical signature. When the cloud's chemical composition was analyzed, scientists found an incredibly high ratio of iron to magnesium that was 10 times higher than the interval/ratio in the Sun. Astronomers believe that the first-generation star with a mass of 300 times that of the Sun, bursting in a supernova known as a couple of supernovae, is the sole interpretation for this cloud of debris. A couple of supernovae, which have not yet been detected, are thought to occur as massive stars with energies between 150 and 250 times that of the Sun near the conclusion of their lives. One theory states that light in a star's core spontaneously transforms into negatively charged electrons and their positively charged opposites, positrons, during the tremendous cosmic explosion. This releases the electromagnetic pressure that keeps stars from falling to Earth during their lifetimes. The star gravitationally collapsed as a result, and the star's outer layers are vaporized in a supernova explosion that follows. We've been keeping an eye on the facts on how supernovae are obliterating stars and what else is happening in the universe as a result. We now know that there are some celestial bodies in the universe that seriously harm stars. Continue watching the entire video for more of it, and be sure to subscribe to our channel for more content just like it. However, a couple of supernovae do not do this. Instead, they eject their entire contents into space. Black holes, or supernovae, are the stellar byproducts of typical supernovae. The only means to track these supernovas are to either witness them as they happen, which is highly improbable given how vast space is, or to determine the chemical composition of the debris they eject. This signifies that it is possible to find them by looking for star remains. However, a couple of supernovae do not do this. Instead, they inject their entire contents into space. Black holes or supernovae are the stellar byproducts of typical supernovae. The only means to track these supernovae are either to witness them as they happen, which is highly improbable given how vast space is, or to determine the chemical composition of the debris they eject. This signifies that it is impossible to find them by looking for star remains. The components of a cloud or air absorb and emit light at specific wavelengths, leaving different fingerprints on the light that passes through them. Spectrographs like GNIRS can determine the chemical composition of the cloud by using the light to recognize components by their distinctive fingerprints. Scientists at the University of Tokyo developed a method that takes advantage of the power of the light wavelengths emanating from a quasar's light spectrum to address this problem. With the aid of this technique, the scientists were able to assess the abundance of a number of elements in the clouds that were in close proximity to the galaxy, which showed an abnormally high concentration of iron relative to Mg. Yoshi and his colleagues claim that this provides the clearest proof of a population 3 star, and a pair instability supernova to date. To determine whether similar quasar clouds share these characteristics, the team is interested in investigating them. Although the explosion could be visible from a great distance since high-mass population 3 stars would have completed their lives long ago, their chemical traces might be found closer to home. The team hypothesized that the pair instability signature may persist for a very long time, suggesting that the remnants of long-dead stars may likewise be engraved on local galactic objects. Watch more videos of our playlist with similar contents. With that, we come to the end of this video. Comment down your thoughts on this content. If you like this video, do like, share, and subscribe to this channel for more facts. Also, check out our other videos on our YouTube channel.